All right, so this example is objective number 4. In this example, we're going to look at how to rewrite an algebraic expression that has a negative exponent in a way that doesn't have a negative exponent. This is going to be a really sort of a quick example, but I want to kind of take it apart a little bit to make sure that we understand what's going on in it so that when this arises in context of a more complicated problem later on, you'll know how to handle it. So the strategy here is we got an expression 4v to the power negative 4. And we want to rewrite it in a way that has no negative exponents in it. So the strategy is I like to call find the power. And what I mean by that is we need to know where the arithmetic is actually happening in the expression 4v to the negative 4. And once we've located it, what we're going to do is we're going to change in the exponent what used to be an operation we can think of as subtraction into an operation we can think of as addition instead. In other words, trading a negative number for a positive number. So how we're going to do that is by making reference to what I like to call the layer cake of arithmetic. And in a layer cake of arithmetic, we have the most basic operations on the bottom layer, addition and its inverse, subtraction. And on top of addition and subtraction is built multiplication and division. After all, multiplying is nothing more than a repeated process of addition, especially if we're talking about whole numbers. And on top of multiplication and division is built the highest order arithmetic of exponents and roots. And what I like to do to organize my thoughts about exponent and power arithmetic is to think that whatever operation is happening in the exponent is happening to the whole power of the exponential expression at one layer higher on the cake. In other words, for this example, we're going to need to know that if addition or subtraction is happening in an exponent of an exponential expression, that means that multiplication or division, respectively, are happening to the power that contains that exponent. And so if I want to trade subtraction of an exponent for addition instead, what I'm doing at the level of the powers is I'm trading division for multiplication. So if I trade multiplication for division at the level of the powers, then I'm trading addition for subtraction at the level of the exponent and thereby changing the exponent from negative to positive. So that's the overarching sort of theoretical framework strategy of what we're about to do. So let's get into the details. In the expression 4v to the negative 4, where is the power? So what's the base and what's the exponent that we see in this expression? And it's very tempting to think that the base is 4v when that's actually not the case. If we label where the operations are happening, we know what the exponent is. The exponent is negative 4. But what base is that exponent being applied to? And the key here is that in between that 4 and that v is a hidden operation. There's a multiplication sign that we don't write, but we should probably put it in there to remind ourselves. Right? After all, exponents are higher in the precedence in the order of operations than multiplication is. And for that reason, the exponent negative 4 here does not apply to 4v. It only applies to the thing which the negative 4 is right next to. Namely, it applies to the v itself. Because the multiplication that happens between that 4 and that v happens after the exponent negative 4 is applied to the v. So all of that is to say that the power which exists in this problem is the power v to the negative 4. And that 4, that extra 4 that's out in front is a numerical coefficient. That multiplication by 4 happens only after the power v to the negative 4 is computed. So now we know what the base is and what the exponent is in this problem. Which means that all the work that we do is going to be done inside of that green box. Right? We're going to just work at the level of that power. And inside of that power, I want to change the arithmetic that's happening in the exponent. Namely, I want to change that negative 4, which is in the exponent, to a positive. So if I want to change subtraction for addition, in other words, change the negative sign to a positive sign, if I want to do that in the exponent, then at the level of the power, what I should be doing is I should be changing multiplication for division. So in other words, to achieve the swap that we want in the exponent, to trade negative for positive, what we can do is instead trade the operation which is in front of that power from multiplication to division instead. So what's that going to look like? Well, the exponent now is going to be positive 4 instead of negative 4, which is what we wanted in the first place. But the operation in front of the power is no longer multiplication. It's not 4 times v to the power 4. Now it's division, 4 divided by v to the power 4. And at this point, that's basically a completed solution. It's just not written in the way that is most conventional to write the result of a division problem. So we're just going to gussy it up a little bit by rewriting the division sign, which is kind of archaic, using a fraction bar instead. So just transform that division sign into a fraction bar whose numerator is that 4, and whose denominator is v to the power 4. So that was a lot of talk for a step that hopefully is going to become automatic in your repertoire in this part of Unit 2. The step is, how do we trade a negative exponent for a positive exponent? And the answer is, just take the whole power, remembering what the power is. In this example, it included the v, it included the negative 4 exponent, but it did not include the 4 that's out in front. Take that whole power and trade multiplication for division. Basically, what we've really done is we've just taken a v to the minus 4, which lived in the numerator of an expression, and we've dropped it down into the denominator. So we've just traded places. It used to be upstairs, now it's downstairs. And when you go from upstairs to downstairs, you change the sign of the exponent. So how do you rewrite an expression without a negative exponent? Make the exponent positive and move the whole power that you just changed from multiplication to division, either from a numerator to a denominator, or maybe vice versa, from a denominator into a numerator. Again, this is an example that hopefully you'll get a lot of practice doing within the context of other problems as you go forward in Unit 2.